without compromise. Educating you without compromise.
Good day, my Ss2 students. I want to welcome you to our online class of today. My name still remains Austin Okieme, aka Austin Nines. Today we are going to be looking at the topic logarithm. Now, what is logarithm? Logarithm is the inverse. Logarithm is the inverse operation of indices. The inverse operation of indices. That is logarithm. You did indices in your SS1 class. Now, let's take, for example, if, let's say, y is equals to 10 raised to power x, then the logarithm of y to base 10 is equals to x. Now, in mathematics, we call this very one here the index form. We say it is in its index form. Why this one? We call it the logarithmic form. Logarithmic form. So we call that the logarithmic form. Now look at this. The logarithm or a number is equal to 10 raised to power its logarithm. A number is equal to 10 raised to power its logarithm. What do I mean by that? Let's say, for example, I have 10,000. 10,000 expressed in its index form is equal to 10 raised to power 4. Now, this number here, this one is the number. Why this 4 here becomes the logarithm of 10,000? So, which means log 10,000 is equal to 4. Is equal to 4. So, that is the meaning. Now, that will now take us to what we refer to as the component of a logarithm of a number. The component of the logarithm of a number. If 2.9936, for example, is the logarithm of a number, these two here, we refer to it as integer or the integer part. You can also call it characteristic. Why this decimal part here is called decimal part, decimal fraction, if you like, call it decimal fraction, or if you like, you can also refer to it as matisa. So these are the two parts of the logarithm of a number. So having said that, let's quickly pick an example now to demonstrate how to use logarithm table to solve an operation. I have a question here, example 1. Say use tables to evaluate, let's say 256.4 times 36.75. So use table to evaluate that problem. This is a problem that you can carry out without even calculator. You can do your normal multiplication to get your answer. You can as well use your calculator to solve that. But in a case where you are asked to use logarithm table, that is what we are here to learn. Now what you do here is this. You draw your table, then you divide it into 2. This part, we call it number. You write number there. While here is logarithm. Under here, I'm going to write the first number there, which is 256.4. While the second number will be written under 36.75. Now, my next assignment is to get the characteristic, the number I'm going to write here and here. And how do we achieve that? In your previous class, you were taught how to express a number in standard form. So I'm going to express this number in standard form, 256.4 in standard form becomes 2.564 times 10 raised to power. I'm moving this decimal point from here to this place. And the number of steps that I took before I got to that place is 2. And that's what I'm going to write there. So this 2 automatically becomes the characteristic that I will write here. I'll do the same thing to this one, 36.75. And this is equal to 3.675 times 10 raised to power. The number of steps I'll move this decimal point from here to here is 1. So I'll put 1 here. This 1 automatically becomes the characteristic here. Now in the subsequent example, I'm not going to be doing that. What I will do is just for you to count the number of digits behind the decimal point. You count the number of digits behind the decimal point and subtract 1 from it. For example, here we have 3 digits behind the decimal point. 1, 2, 3. If I remove 1 from 3, I will get 2. I have 2 digits behind the decimal point here. If I remove 1 from 2, I have 1. So that is how we are going to be solving it in our subsequent examples. Now, this will now lead us to our 4-figure table. Kindly pick up your 4-figure table now. So we are going to be looking at, you turn to the logarithm part, logarithm of numbers. Now, you have to understand that we have 2 types of logarithm. We have what we call the natural logarithm and the common logarithm. The natural logarithm is the logarithm to base e, while the common logarithm is the logarithm to base 10. The one we are looking at now is common logarithm. So I'm saying this so that you will not go and be looking for it under the natural logarithm. That will give you the wrong answer. So you turn to logarithm of numbers as it is on my own. Logarithm of numbers as you can see. Now, under that logarithm of numbers, you now come to the number here. Pick the first 2 digits. The first 2 digits here is 25. So you will say 25 under 6 difference 4. So you go to your 4-figure table, locate 25. So 25 is here, 25 under 6. The number I have here is 4082. So I have 4082. So 4082, 25 under 6 is 4082. Difference 4. I go to the difference portion. Difference 4 is 7. So I will add it. We usually add the difference. So this will give me 9804. I'll come and write it here. 4089. I do the same thing here. 36 under 7 difference 5. 36 under 7. 36 is here. Under 7, that is 5847. Then difference 5. That is 6. 5847 plus 6. 5847 plus 6. If I add that, this will give me 3. Here is 5, 8, and 5. So I have 5853. Now, when we are multiplying, we add. So we are going to add this now. This plus this will give me 2, carry 1. If I add 1 to this one, that is 9, plus this 4, carry 1. 1 plus this is 9. Then here is 9 point. This plus this is 3. Now, what do we do here? We're almost there. Ignore these 3. This is called the characteristics. We are going to work with the decimal part now. You now turn to what we call the antilog. Antilog table. Antilog is like the opposite of logarithm. So you turn to antilog table. The same thing we did here, that's what we are going to do. 99 under 4, difference 2. So I look for 99 here. 99 is here. The last one there is the last number there. 99 under 4 is 9563. 9563. So I have 9563. Now I said difference 2. 9563 difference 2 is 5. So I add 5 to it. That will give me 8659. So I'll come here. I'm going to write this here. 9568. Now somebody might be asking or wondering, why did I leave this 3 out? No, I didn't just leave it out like that. The time has come for us to make use of this 3. So how do we use this 3? I'm going to add 1 to this 3, and I will use it to put the decimal point in the correct position. Like I said before, Any number you check from your four-figure table is a decimal number. It's not a whole number. There is a decimal point here. To make it obvious, I can even decide to put 0 here, 0 point. To let you know that it's a decimal number. It's not a whole number. Now, I want to reposition this decimal point. How do I do that? If I add 1 to 3, that will give me 4. Now, it means move this decimal point 4 steps forward. If you move it 4 steps forward, it's going to be here. So my final answer still remains 9568. If you want to make it obvious, you can decide to put 0.0. But it's not necessary. So you can just remove it. So it becomes 9568. So this is how to use logarithm table to evaluate an operation of this kind. And I believe you understood everything that we have done. So we are going to be stopping here, and your assignment is going to be forwarded to you, via other platform. So I still remain my humble self, Mr. Austin Okieme, aka Austin 9. See you in our next online class. God bless you.